everyone. This is our 14th period of matrices, and in matrices today we are discussing symmetric matrix and skew symmetric. First I explain you what is symmetric matrix. Symmetric matrix means in a matrix if we interchange all the rows with column, that means if we write transpose of a matrix, then again we get the same matrix, that is called the symmetric matrix. See, I write one matrix in which I have written matrix A. Now if I write its transpose, if I write its transpose, then what is its transpose also? 1, 2 as a first, 2 minus 1 as a second column. What is the meaning of it? When I have written matrix A, its transpose means matrix and its transpose both are same. In this condition, if transpose and matrix is same, it is called symmetric matrix. Now this one I have written in 2 by 2. Same way we will take one more example of 3 by 3. 1, 2, 0, 2, 1, 0. Either we will take again 2. Now third 0, 2 and 1. Now if I have written this matrix, if I write its transpose, what is it? 1, 2, 0 as a column, 2, 1, 2 as a second, and 0, 2, 1 as a third. Check it. Matrix A and its transpose both are same. What is the meaning of it? If we write all the rows in a format of all the columns, and if you get the same answer, this type of matrices is called symmetric matrix. Now second definition is a skew symmetric matrix. In a skew symmetric matrix, what to do? Let's see. Skew symmetric matrix. Skew symmetric means if you interchange all the rows with all the columns, and if you get additive inverse, means when you write transpose of a matrix and if you get with minus sign matrix A, then you can say it is a skew symmetric. Let's take one example. First we take example of 2 by 2. I have taken 1, 2, minus 2, 0 matrix. Now I write its transpose. So I can write 1, 2, minus 2, 0 this way. Now check, I have taken minus 1, 2, minus 2 and 0. So if I write its transpose, then this will be minus 1, 2, minus 2 and 0. Now if we take minus sign outside, then what you will get? This will be 1, 2 and minus 2, 0. By mistake I have written this matrix, let me change. Skew symmetric means we have to take 1, 0, 0, minus 1. Let's take this matrix. Then what you can write? Transpose of this matrix is 1, 0, 0, 1, 0, 0, minus 1. Now check. Here can we change? If we take minus sign outside, we will get minus 1, 0, 0, 1. So this matrix is not a skew symmetric. When you take minus sign outside, and if you get the same matrix, then you can say it is a skew symmetric. Let's take one more example of skew symmetric matrix. So it will be more clear to you. For skew symmetric, we are taking one example. Matrix A as a 0 E F minus E 0 G minus F minus G 0. Now check. When you write its transpose, what is its transpose? 0, E, F, minus E, 0, G, minus F, minus G and 0. Now check. If you take minus sign from this, then you get 0, E, F, minus E, 0, G, minus F, minus G, 0. Check it. Both matrices are same. Matrix A with minus sign. What is the meaning of it? When you write transpose of any matrix and if you get it's equal to with minus sign your original matrix, then you can say it is a skew symmetric matrix. Now remember, in a skew symmetric matrix normally this principal diagonal always 0. Then what you have to check? You have to write the upper part with plus sign, then lower part with minus sign. That way only you can set your skew symmetric matrix, because what is when you interchange row with column, then minus sign you have to take outside. So one portion with plus sign, then second portion will be with minus sign. So remember, principal diagonal you have to take 0 and you just change the element with plus or minus sign, you easily get the skew symmetric matrix. Now for symmetric and skew symmetric matrix, we will discuss its theorem. Your first theorem, that is the sum of matrix and its transpose is a symmetric, means A plus A transpose is always symmetric. And second, A minus A transpose is always skew symmetric. Now let's start with one example. We are taking matrix A 1, 2, 3, 4. Now let me write its transpose. So 1, 2 as a column and 3, 4 as a second column. Now let's add it. A plus A transpose. What is it? 2, 1 and 1, 2. 2 and 3, 5. 3 and 2, again 5, and 4 and 4, 8. Now just write its transpose. A plus A transpose, we are writing again its transpose, means I just simple change row column. So 2, 5 first row written as a first column, 5, 8 written as a second. Now check, A plus A transpose and its transpose both are same. If this situation is there, this is your first theorem of a symmetric skew symmetric matrix, that sum of matrix and its transpose will be always symmetric. Now the same example we will continue for skew symmetric. So in skew symmetric what to do? Only subtraction. So let's take the subtraction of it. So A minus A transpose. Now subtraction, 1 minus 1, 0. 2 minus 3, minus 1. 3 minus 2, 1. And 4 minus 4, 0. Now write its transpose again. So what is it? We have to change first row as a first column and second as a second. Now check this matrix and this. When you take minus sign outside, you get the same matrix. Check. So A minus A transpose is a skew symmetric because outside we have minus sign. So this is your theorem number 1. First theorem, that sum of matrix and its transpose is always symmetric, and subtraction or difference of matrix and its transpose is always skew symmetric. This is your first theorem. Now the second theorem is, let's take the second theorem. Theorem number 2. Second theorem, for any square matrix which can be expressed as a sum of symmetric and skew symmetric. Sum of symmetric and sum of skew symmetric. So if I write sum of symmetric, sum of skew symmetric, that means if I write half of and half of this, then you will get your original matrix A. Now let's check it. We are not considering this, just we are solving this part. What is the meaning of it? Half of A plus half of A complement. Similarly, half of matrix A and half of matrix A complement. Now check this two with plus or minus. So we can cancel it. So plus or minus A transpose is cancelled. Half of A plus half of A will be your half and half 1. You can write A also. If you don't get this way, you can take LCM and you can write 2A by 2 equal to A. This is your second theorem, that if any square matrix can be expressed as sum of symmetric and skew symmetric, that I have taken with example A. Now we will take one example for this and we will prove our first theorem, this theorem number 2. Let's take one example. Suppose we are taking matrix B. Matrix B as 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. This is your textbook's example only. Now we will write B transpose. So what is it? First row we will write as a first column. Second row we will write as a second column, and third row we will write as a third column. Now let's add it. B plus B transpose. 2 plus 2 will be 4, minus 2 minus 1 minus 3, minus 4 plus 1 minus 3, minus 2 minus 1 minus 3, 3 plus 3 is 6, 4 minus 2 will be 2. 1 minus 4 minus 3 minus 2 plus 4 will be 2, minus 3 and minus 3 minus 6. Now what is our theorem? Half of A plus A transpose. So when I write half of it, what is it? Half of B plus B transpose. So what is it? I have to divide all the terms by 2. So if I divide it by 2, then what I get? 2 minus 3 by 2 minus 3 by 2. Then second again minus 3 by 2, 3, 1, minus 3 by 2, 1 and minus 3. Okay, we will keep this as it is. Now we will write B minus B transpose. Now B and B transpose subtraction. So let's take subtraction. 2 minus 2, 0. Minus 1 minus minus plus 1, minus 2 plus 1 will be minus 1. Minus 4 minus 1 will be minus 5. Minus 1 minus minus plus 2 will be 1. 3 minus 3 will be 0. 4 minus minus 2 will be 6. Minus minus plus. 1 minus minus 4 will be 5, because minus minus plus. Minus 2 minus 4 is minus 6. Minus 3 minus minus plus, so 0. Now again write half of B minus B transpose. So let's divide it this also by 2. All the term will be divided by 2. 1 by 2, 0, 6 by 2 is 3. 5 by 2 minus 3 and 0. Now when you add these two, you will get your original matrix B only. So half of B plus B dash, half of B minus B dash will be your matrix B. Check it, we check one first row. 2 plus 0 will be 2. Minus 3 by 2 minus half. Minus 3 by 2 minus half means minus 4 by 2 will be minus 2. Similarly, minus 3 by 2 minus 5 by 2 minus 8 by 2 means 4. That way you can check remaining elements. So this is your theorem number 2 and its proof also. Now I think our explanation part for this is completed. So we start exercise 3.3. Okay. In the beginning of exercise, one simple question is given. First one, write the transpose. Write the transpose means what to do? We have to simple interchange rows with columns. So let's start with first. First matrix is given A equal to 5 half minus 1. So how can I write its transpose? 5 first row. So column matrix we can convert it into row matrix. Now second one, second matrix is 1 minus 1 2 3. So its transpose will be 1 minus 1 2 3. Now third is 3 by 3 matrix is given. So minus 1 5 6 root 3 5 6 and 2 3 minus 1. So now let's write its transpose. Suppose this is your matrix A. So we can write row as a column, root 3 5 6 and 2 3 minus 1. So this is your first question, in which 3 question is given. One is column matrix 2 by 2 and 3 by 3, and we have written transpose of all. Now second question, in which you have to verify the property for addition and subtraction. So let's take second example. In second example, A is given -1 2 3 5 7 9 -2 1 1 and B is given -4 1 -5 1 2 0 and 1 3 1. Okay, let's add it first. You have to find A plus B transpose equal to A transpose B. So let's first add it. -1 -4 -5, 2 and 1 3, 3 and -5 -2, 5 and 1 6, 7 and 2 9, 9 plus 0 9, -2 and 1 -1, 1 plus 3 4 and 1 and 1 2. Now take A plus B transpose equal to, what to do? Row I written as a column 6 9 9 and last -1 4 and 2. Now we have to write A transpose plus B transpose. Let's write transpose of it first. -1 2 3 5 7 9 and -2 1 1. What I have written? Row I have written as a column. Now -4 1 -5, second 1 2 0 and 1 3 1. Let's add it. -1 plus -4 -5, 5 and 1 6, -2 plus 1 will be -1. Same way check second, 2 plus 1 is 3, 7 and 2 9 and 1 and 3 is 4, 3 and -5 will be -2, 9 and 0 will be 9 and 1 plus 1 will be 2. Check it. A plus B transpose and A transpose plus B transpose, both answers are same. Now we will take third example. No, it's the second one is remaining. So let's solve second one. Now second question is A minus B. Let's subtract it. -1 minus plus 4 3. 2 minus 1 1, -3 -5 8, 5 minus 1 4, 7 minus 2 5, 9 minus 0 9, -2 minus 1 -3, 1 minus 3 -2 and 1 minus 1 0. Write its transpose A. So 3 1 8, 4 5 9 and last -3 -2 and 0. Okay. Now let's write A transpose minus B transpose. Your A transpose will be -1 2 3 5 7 9 and -2 1 1 minus -4 1 -5 1 2 0 and 1 3 1. Now subtract it and by that you check it. -1 minus plus 4 will be 3. So you get same answer. 5 minus 1 4, same answer. -2 minus 1 minus 3 answer. 2 minus 1 1, 7 minus 2 5 and 1 minus 3 -2. 3 minus plus 5 8, 9 minus 0 9 and 1 minus 1 0. So we are getting A minus B transpose equal to A transpose minus B transpose. So with this our second question complete. We continue our third question in our next class. So thank you very much.